Hi, this is Miles Jaffe, recording the video for the CS262 Homework 1, which is implementing the lexer. So, first of all, a lexer is a step in the pipeline of interpreting code. It takes the stream of bits, the raw bytes from the source code, and turns it into, as we can see here, a vector of tokens, which are then used by the parser to actually enable functionality. All the lexer does is take the code file itself and turn it into something that can be more easily read by a computer, which is then used by the parser. It takes as input a text file of raw bytes, which in this case is implemented as a string reference, and outputs the vector of tokens. And a simple example would be this lexer for the ASA language, which takes a very limited number of possible data types. So my implementation here was very much based on what we did in lab 2. I had an iterator and a vector of tokens here. I was keeping track of the current line and column because they are kept track of in the tests. A lot of my implementation here was writing to the test for these 12 given test cases. So checking if the byte is, if the first letter of the byte, I made a lot of this based on the first letter or character of the byte, because that was the most intuitive way to do it for me. So if the first character of the byte is alphabetic, we have to have an identifier, keyword, or a single character alpha. And so there is kind of a little bit of control flow here where we read the next few identifiers until we run into something that is not alphanumeric, so a letter, number, or underscore. This does mean that you can have a number embedded within a identifier. It reads through the identifier until it hits something that is not alphanumeric or an underscore, which in most cases is going to be white space or some kind of operator like brackets or a slash. At that point, it stops parsing, breaks, and checks if it's a keyword. If it is, pushes the keyword. If it's not, checks if it's an alpha or an identifier by checking length. Similar process goes on for a digit and integer, except it just has to be ASCII digits. When we're checking for string literals, this was definitely the most difficult part to implement, and not even something that I necessarily needed to implement. But I felt like including, in addition to the functionality that was shown in Lab 2, the ability to have a singular quote, as specified in the documentation, a singular quote. Normally when the parser for a string literal sees this opening quote, it's going to read until it finds a closing quote. So I implemented checking for a singular quote with no closing quote, or at least no valid, non-escaped closing quote, as recursively lexing through the rest of what the string literal parser brought back. Because if there's no closing quote, it'll read all the way to the end of our input. So we just have to read the rest of the input while keeping track of columns and lines appropriately. It also pops the end of file from this recursive function call because it will be the EOF token, and we only want one of those. And I'm definitely not worried about any kind of infinite recursion when I do this recursion, because this can only happen once. Because by definition, if we are here, then there's no more opening quotes, there's no more quote marks in the rest of the input. And that is implemented here. I also wanted to take a moment to talk about my implementation of escape characters in the string. So all characters with special functions are managed in this if-else block. If the byte is another quote, then it breaks. If the byte is an escape character, it makes this Boolean escaped true. And if the previous byte was escaped, then neither of these can happen because this triggers first. This does enable us to have escape characters within a string literal, as I'll show you in some of the tests. In terms of individual characters, most of this block was verbatim from Lab 2, although I added some of this stuff as specified in the documentation. The individual quotes, digits, alphas, all happen by different rules because they have the same starting character as identifiers, integers, string literals, so they have to be processed as a special case of those. And we also need a way to increment the line for these tests that specify line numbers. And then is push to tokens if it's not a white space member. And obviously at the end, we push an EOF as we did in Lab 2. I did my best to write to the tests, just in terms of preparing the code as it would output the tests rather than what was in the README. I thought these took precedence. So when I was writing my own tests, the first few of these were adaptations of what was in the README. We can have an empty string literal. A keyword is not mistakenly found in an identifier that contains it. We can have those escaped quotes I was just talking about. It's possible to have a commented outline. I should talk about the commented outlines. So in this block, I should also talk about the mainline escape characters. If we have something that shows that there is a comment, then it just runs to the end of the line until we find a new line character. Whoops. And to do this, I took advantage of the fact that a / for division was not specified in these individual tokens. So there was no need to think about, oh, what about division? Because division is not within scope. For /, I used the same escape character trick as with the string literals. So the /, an escaped out character creates a token with content of length 2. And I used option stuff to make sure that if we had an escape character at the end of an input, then that would be an other token of just length 1 that was just the escape character. So comments end after a new line. Now here's where we start the test that I wrote. We can have a singular escaped character. We can have just a lonely escape character. There can be a single quote, and that's parsed correctly. This block of code is supposed to hit this stuff, which sees that there's no closing quote and that the function to parse the string literal read all the way to the end of the input, and parses it rather than continuing to read. There can be a single quote alone, so that just to make sure that this block doesn't go crazy when it sees that there's nothing after the singular quote. That's what this if statement is for. We also have to have a singular quote when the closing quote is escaped. So with the closing quote escaped, this should be a singular quote, an identifier, and some mysterious escaped out character that we can't parse. And I also wanted to test the curly brace identifiers because there's not much about them in the default tests. The most challenging part to implement here was definitely the parsing of the rest of a mistakenly read in string when there's no closing quote. This took me a while to get right. I was on the wrong track for a while trying to set the iterator to the rest of the content string, but obviously it was out of scope. I tried to avoid using AI because I wanted to learn all of this for myself. I did talk to Copilot. That's oh no, where is it? In this window, but it doesn't seem to have preserved the sessions. In any case, that was more for advice, judgment, general ideas than for actually writing any code. Unfortunately, I have no idea how to preserve the in-browser sessions. It doesn't even preserve them when you close VS Code. So let's run the cargo test. And as you can see, all 12 tests and all 10 of my custom tests work fine.